One thing worth noting, while cutting these pieces, I'm intentionally cutting them short, anywhere between 60 to 100 thousandths short. So that'd be a 1/16 of an inch to not quite an 1/8 of an inch. You never want to do anything line to line because then you have no clearance or no ability to accept variation. Now I'm trying to cut as square as I possibly can to reduce the amount of variation that I'm going to get out of this. But one thing I cannot control is the flatness of this floor. So there are waves in any slab. And if I cut these just a little short, if this end's a little high or low, nominally, if you will, that's going to change the angle of the cut, not necessarily as we see it here perpendicular, but it's going to raise the end so that it kind of slices at an angle. It might still be square in one direction, but it's not in the other. So if we can keep our cuts just a little bit short, we'll help our parts go together and be able to accommodate a greater variation. So these are the pieces that I'm making that'll go directly under the table, and they'll go transverse to the main length of the table. So they're just under 3 feet long. And I'm considering doing 3 or 4 of them. I've cut 2, and the whole time I've been cutting square to the material with the material laying flat in the saw. When I do that, the top flange of the material being cut takes a really long time, and so does the bottom. Presumably that's because the blade is dragging a longer arc length as it goes through the material, slows the motor down, and just takes longer, rather than when it goes through the vertical edges and it's going across a very short cross section, in this case 1/4 of an inch, it cuts much faster. So what I tried to do was take this piece and roll it up on its edge such that I'm kind of cutting through a diamond shape or profile, thinking that maybe that would help with the arc length and the cut speed would be faster. What I ended up with was an extra problem. Let me show you what I'm talking about. So if we take and measure across here, it's supposed to be between 30 and 7/8 and 30 and 15/16 of an inch. This cut started in the correct location. But when I turn everything up on its edge, I think my cut got thrown off because of the flatness of the floor. Every slab's going to have some kind of waviness in it as it goes across. It's never going to cure perfectly flat. My slab is no exception to this. So I try to support things a long way out to get as square of cuts as I can. I can set things up square in the saw, but if the material is set in there kind of cockeyed, if you will, it might be square in one direction, but it's going to cut at an angle in another. And I think that materially contributed to this situation. If we roll this over and look at the back side, what we'll find, rather than being where we wanted to be, we're 31 1/8 of an inch. So what I think this has done is by having the material sitting, in this case it would be up, I think, no, down. The blade as it came through here, slowly went off to the side. And you get that deflection in the blade and it kicked it out, in this case, almost 3/16 of an inch. I didn't pick up on it due to just the noise vibration of not only the saw, but the generator running the saw, until I was almost all the way through the cut. So I'm going to have to come back in here and do quite a bit of cleanup on this to get this thing back square or even where it'll fit. It doesn't have to be perfect. Like I said, I like a little bit of gap. It helps get the weld down in there, gives me some tolerance to play with things, but this is definitely going to have to be cut or cleaned up quite a bit. So all the pieces that go around kind of the lower skirt, and then also around the top just under the table that lay horizontally, I'm going to come in and bevel these with the grinder so that I can get more penetration through the material depth all the way around this and get a better weld. So when I get done grinding, it looks like this. I try to hold it at about a 45-degree angle, and go about halfway through the thickness of the material. I don't want to go all the way down. I still like to leave quite a bit of meat on the edge for penetration to knock into, but I do try to help my weld out, and it looks like this when I'm done. Getting the clamps set up to hold this and hold in square. And you may notice there's numerous numbers and markings on the outside of this. Trying to not just use the framing square to check square, but actually go corner to corner. And right now I'm about a 1/16 of an inch short from square. If I hook on the outside of that corner over there and kind of extrapolate to where this corner would be if it was chopped. But since I also have run the grinder around the corner over there, I would expect to be just a little bit short. So I think I'm sitting pretty good on squareness. Running the numbers and using the pencil. If you don't know, you can use your digital assistant, or in my case Siri, to do math for you. It'll do basic arithmetic, square roots, and things of the like just by asking the question, and I'll pencil the numbers down and ask my next question rather than having to type all that out in the calculator. So I'm running out of clamps. I've tacked these two pieces together, and I've put this last leg in, and just for looking at it purposes, I've placed the piece as the lower skirt in its approximate location. I don't have the ability to hold down on that back corner. If I had the clamps or anything else that I could use my holes in the middle, which are intended for putting a clamp to hold something down, I could better hold some of this had I worked off that corner, but I don't have any of those at this point. So what I'm going to try to do is, with these two welded together, I'm going to try to tack on one side this fourth leg. And I'm going to take this clamp, move it to the other side, and I've got my last pair of vice grips. So I'm going to try to hold this stiffening piece in next to the leg, and then try to tack here and here, with the intent that if this thing, or when this thing tries to move, it's going to try to move out against my reinforcing piece. So I don't want to do something to cause it to move in, but if I can at least hold these together enough by tacking here and here, that may be sufficient to hold the leg in place while I try to tack in the lower skirt. Now I don't have anything in addition to try to hold over and clamp that in place. I'll have to use willpower to try to get it in there. Maybe I'll try some wedges or something like that, but getting that skirt in there exactly where I want it without everything moving on me may get a little tricky. So here we see post-processing. And I don't know if it helped or not. I elected to do the bottom tack first. I don't know if there'll be any vertical, either positive or negative component trying to pull this thing, but if there was, I wanted to try to bias that to the bottom, so I did it first, so it would try to, if it's there, it'll pull itself into the table, and then do the top, such that this clamp is trying to restrain any other upwards motion. So got those two in, got a little close to my brand new tabletop, but it's not welded to it. We'll see how the lower skirt piece goes in. As I prepare the substructure, I've been mindful to try to always measure off of the face that will be in contact with the bottom edge of the tabletop up here. I'm trying to make sure that when I'm done, not only is this plane at the top straight with the tabletop, but so is my bottom skirting. I can let my run out on the bottom of the legs float just a little bit, and that'll be fine, because I'm going to have an adjustable foot so that I can level this table, and it's going to be a little bit different. I look forward to showing you that, but trying to emphasize always measuring off of the same side, no matter what you're doing, can help you control where your run out goes to. Moving back around to the bottom side. Now that this corner is tacked, I've been trying to think through how I can best hold this lower piece in place. I'm going to try putting tack welds on the upper surface on one end so that any pull is going to try to lift the whole thing, and I can use my weight on the other end to push it back down. And I'm going to avoid putting anything on those vertical edges in that fillet zone to try to minimize the extra pull that will come out of plane. I've got it tacked on now, and what I ended up doing was placing a single tack in the middle of the face on that edge. So I only put one tack on that on the top so I could push down. If I needed to, I could put a pipe wrench over here and roll it just a little bit. It didn't try to move on me, at least noticeably. And then down here, I put a tack in the middle. And as soon as that was held, I jumped to the top corner as you see it, put a tack over here, and then came back down to the lower corner over here and tacked that. So trying to keep this thing from twisting out of plane. I think that'll be enough to let it hold its shape. I'll go ahead and put some more tacks on this and probably weld down those two top edges to try to get this thing set where I'm not concerned it's going to move on me. When it's all said and done, it looks something like this. I've done some of this welding with a 1/8 inch 6011 and some with the 5/32 rod. I can't remember. This looks like it may be the 5/32 rod. I was running it at about 130 amps on the Blue Star 185. But I did get ahead of myself. I intended to only weld across the top and then weld across what's shown here on the bottom that'll be against the table surface, and got ahead of myself and welded across here. I didn't do that on the under section here. That's still tacked, but I really just want to get the top and as you see it here, this upper piece and then that lower piece down here that'll be against the bottom of the table when this thing's flipped over, held in place. And then I have the ability to tack everything else in so that I'm not putting heat into it that's making this thing want to twist while it's going through all that heating. I'd like to get it all tacked together, pulled down tight to the table, and then weld everything out. And one problem that's going to cause is between these two main frames, short way on the table, when I weld the equivalent piece onto this going the other way, I'm not going to get this edge here that'll be against the tabletop welded across it. But I've done the primary direction that would see any bending. It's tied on both sides, and I think I'll be okay across the shorter section of the table by leaving that one weld out. And the tabletop's going to be welded to it anyway. Same day I'm doing all the tacking, I got on Craigslist and found this one Pittsburgh clamp. It's old, it appears to have never been used, and it's got that old school Pittsburgh low qualityness to it. But for 200 nickels, I was able to pick this up. I think it'll be worth the 10 bucks it cost me, and certainly help as I try to put this table together and holding something on the other side in place for me. So I appreciate you watching, and as you do your projects, work hard but don't overdo.